Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we talk about all things Gen Chem related. On this video, we're going to be learning about electrolytes versus non-electrolytes. Let's get started. So in a previous video, we learned what solutions are. Remember, solutions contain solutes and a solvent that have come together to create this homogeneous mixture that we can now call a solution. And so why do solutes dissolve in certain solvents? Well, the reason that is because of these things called intermolecular forces, or these attractive forces that are able to hold and attract the two things together. There are a certain type of force that the solutes have, and then other forces that the solvent has. If those two forces match, then they will likely form a solution. And so the two independent things, the solute and the solvent, have to overcome their own independent attractive forces in order to be attracted with one another. And so remember this rule, it's the chemist's rule of thumb, like dissolves like. And we'll talk about that a lot in chapter 11, but that's what's really happening and allowing these solutes to dissolve. Again, if the attraction between the solute and the solvent are strong enough, the solute will dissolve and create this homogeneous solution. So if we look at table salt, remember table salt or sodium chloride is considered to be an ionic compound. Remember, ionic compounds have these positive cations and negative anions that are found in this crystal lattice structure. So as it's interacting with the solvent, the water, these cations start to dissociate or pull apart from one another, from the anions, and you end up with these freely charged particles floating around in solution. Now, those positive and negative areas are then attracted to different regions in the water molecule, again, through these intermolecular forces, and that allows the water to actually surround these ions and allow them to become a homogeneous mixture. And so as a result, in these ionic solutions, you have these freely charged particles that are floating around, and then we create a solution that can now conduct electricity. So if we compare an electrolyte versus a non-electrolyte, and you've probably heard this term before, if you think about something like Gatorade or a sports drink, it talks about the idea of these electrolytes. So what is an electrolyte? Well, an electrolyte is a material that is dissolved in water and creates a solution that can now conduct electricity. So for instance, if we have these positive and negative ions that are floating around in solution, that would be something that can conduct electricity through that solution. So that would be considered to be an electrolyte. And so you can see this on the image here where we have this light bulb, and this is really a common physics experiment where we would be able to conduct that electricity through the solution. Now, molecular compounds are a bit different. They don't have that dissociation process that's occurring. They don't have these positive and negative ions that are being created. And so as a result, that particular solution, although it creates a homogeneous solution, it cannot conduct electricity. And so that would be considered a non-electrolyte. So going back to our sports drinks, if you look on the back of the bottles, you'll see that they have some ionic salts that are present, and that's what's creating that electrolyte solution. Now, if we take a molecular view at the electrolytes versus non-electrolytes, again, in order to conduct electricity, there have to be these charged particles that are flowing in the solution. And so electrolyte solutions are those that contain ions that are coming typically from ionic compounds. Now, typically, non-electrolytes are the result of molecular compounds that are being dissolved in water, like sugar. And for the most part, they're not going to ionize. You don't have this dissociation, and so therefore it would be a non-electrolyte, with the notable exception of molecular acids. Now, in another video, I'm going to talk about molecular acids and get into the naming of them. But molecular acids, remember, acids have that H that come in front of them, so like HCl. And so that actually does have this ionic property inherent to them. So you could have these positive ions and negative ions that would dissociate in solution and create an electrolyte solution. So with the exception of molecular acids, most molecular compounds are non-electrolyte solutions. And so now if we visually compare sugar versus salt, what's happening in water? Again, in the ionic solution, when we're creating this electrolyte, we're going to have these positive and negative ions breaking apart from each other, dissociating. And those positive and negative areas are able to interact with the water molecules, the charged regions of the water molecule, or the more polar regions of the water molecule. And the sugar solution, now the complete compound is actually being associated with the water, and it's being incorporated and dissolved into that solution. I hope this video helped you understand the difference between electrolytes and non-electrolytes. Be sure to come back and check out more videos. Make sure you like, comment, and subscribe, and let me know what kind of content you want to see in the future. Have a great day, and I'll talk to you later.